Hey everyone, this is a white line following robot that detects and follows a white path on a dark surface using IR sensors. This IR sensors sends signals to the AT51 microprocessor, which processes the input and controls the motors to keep the robot on track. This project demonstrates the use of AT51 in robot control, sensor interfacing, and automation applications.
So if we come to the working of this project, it works on the simple principle of light reflections. The IR sensors continuously emit infrared light which gets reflected differently by black and white surfaces. White surfaces reflect the IR light back, giving it a logic 1, while black surfaces observe it, giving it a logic 0. Here we are using two IR sensors, one on the left and one on the right. Their outputs are connected to P2.0 and P2.1 of the AT51 microcontroller. The microcontroller continuously reads these inputs and based on the sensor combination controls the two DC motors through the motor driver. We've connected the port 1 pins from the microcontroller to the IN1 to IN4 pins of the motor driver module. The motor outputs are connected to the left and right motors. For power, we used a 7.4 volt lithium ion battery which directly powers the motors and also feeds the AT51 development board through its VIN pin. All grounds are connected together to maintain a common reference. In operation, the microcontroller constantly processes sensor data, compares it to the logic conditions, and sends signal to the motor driver to adjust motor movement in real time. This is how our project works.
So here I will explain the working of our assembly program that is used in our line follower robot. Our robot is designed to follow a white line, but it does so indirectly. The sensors are placed on the black regions on both sides of the white track, or like this. So whenever both sensors read 0, 0, it means both sensors are correctly positioned on the black surfaces, and that represents a forward condition for our robot. Other sensor combinations make the robot turn left or right to stay aligned with the white path. Now over here org000H, this tells the assembler that the program starts from this memory address. And there's a main label over here, move P1 and P2. So over here we clear port 1. Port 1 controls the motor driver. So writing 00 ensures that both motors are off initially. And P2, here we are configuring P2 as an input port. Our two sensor outputs enter through P2.0 and P2.1, which is basically the IR sensor outputs. And now in this loop label, this is the start of the continuous loop where the robot repeatedly checks sensor values. And now move A, P2, we copy the entire port 2 value into the accumulator. And over here in the next statement, we mask the value so only the lower 2 bits matter. These 2 bits correspond to our 2 sensors. Now case 1. We first check if the sensor value is 0, 0. In our robot, 0, 0 means both sensors are over the black regions on each side of the white line, which is the correct centered position. And now there is ACALL stop and SJMP loop. So SJMP loop here, this jumps back to checking continuously. And in the ACALL stop, basically in our hardware setup and wiring, this condition results in the robot moving forward. Because this routine is mapped to forward movement physically. So that is why it's over here. And now we go to case 2, which is check left, right. And there's a CGA any statement over here. We now check if the pattern is 1, 0. This means the robot has drifted toward the right side of the line, so we must turn left. And similarly, there is ACALL and SJMP statement. Now check right, CJNE A, and then there's this over here. This checks for 0, 1. In this case, our robot has drifted left, so it must turn right to recenter. And similarly, there's an ACALL and SJMP. Now the final case 4, which is 1 1 forward. So this checks for 1 1. Both sensors seeing white means the robot is completely off the black boundary area, so it needs to move to the correct position. Okay, and over here are the motor routines. So move forward, turn left, turn right, and stop. This pattern makes the motors rotate forward. This one activates only the right motor, turning the robot left. This one activates only the left motor, turning the robot right. And this one completely stops both the motors. And this marks the end of the program. To summarize, our robot follows a white line by keeping both sensors positioned over the black surroundings on each side of the line. The code continuously checks sensor combinations and activates the appropriate motor routine to keep the robot centered on the track.